Hello everyone, and welcome to the Samsung AI Forum 2020. My name is Sebastian Seung, and I'm the president of Samsung Research. We're hosting today's session about AI. Because of coronavirus, this conference is being held online, but we want it to be as interactive as possible. So you have all received an email about how to submit your questions online. These questions might be about particular talks that you hear, or they might be general in nature to be addressed to the speakers in the panel discussion that will conclude today's session. I'm really excited to say that we have some incredible speakers ahead, but I'd like to start off this day by describing a little bit about Samsung's research in AI. The title of today's session is Human-Centered AI because, after all, that's what we at Samsung are interested in. We want to have technology that actually benefits people. And to that end, we've built up AI research in traditional AI areas like vision and graphics, speech and language, robotics. We also have a big effort in on-device AI. How can we make our AI run on devices that had limited computational power, limited consumption of electrical power, and so on. And I'll talk about an area which is not AI per se, which is health and wellness, a very fascinating area where we can benefit people by harnessing the power of AI and data and devices. The big picture goals of this talk. I'm not going to tell you about AI research per se. I'll leave that to my speakers. I want to give you a big picture. I want to show you the big picture within which AI research exists. And to do that, I'm going to show you specific examples of real-world applications of AI at Samsung. And we'll use those as a starting point to understand the big technological challenges that Samsung and AI researchers around the world are facing as we want to make AI's power extend as much as possible and help people as much as possible. Now, a few words about research in a company. I've done research at universities, I've worked at companies, and research in a university is all about freedom. You study what you want, you have fun, you study it because it's beautiful. But research in companies is very much about constraints. We have to solve real-world problems, and that might feel confining, but it also can be, strangely enough, a source of liberation. And we have here a famous quote from Orson Welles, who some people say is the greatest movie director of all time, here shown as a boy genius. He once said that the enemy of art is the absence of limitations. And the story goes, he was explaining how one day he had to make a movie and he had a limited budget. He didn't have enough dollars. But he realized that that limitation forced him to be more creative and more innovative. By solving these problems inside a limited budget, he was able to make a greater masterpiece. And in the best of worlds, that's what corporate research is like. Real-world constraints can stimulate our creative powers. So let's start with vision and graphics, a classic area of AI. And here we actually have a Samsung product pictured, which is a TV. So you may know, if you've gone to buy a TV, that TVs are crazy these days. 8K TVs, they're huge. They have incredible resolution. Real progress in the hardware since HD and 4K, now we have this 8K. But the funny thing is, those 8K TVs often look useless because if you're viewing content that was made in HD, it still looks like an HD TV. You actually have to have high-resolution 8K content to fully show off the immersive experience of that TV. What are you going to do? AI to the rescue. Maybe we can make a convolutional net that takes HD content as input and spits out something that looks like 8K content. A simulation of 8K imagined by the convolutional net. Now, you may know that convolutional nets are tailor-made for this kind of thing. Multi-scale architectures. These are able to produce, and also training with GANs and so on and so forth, these are able to produce extremely realistic upscaled images. And on the right you see an AI upscaler, on the left you see one from a conventional image processing approach. And so that's the kind of approach. Build inside your TV a little AI that can automatically turn HD content into 8K content. Now, that kind of sounds a little bit easy because we know as academics that that sort of thing is possible. It turns out it's not that easy to get it to run on the limited processing power of the TV, and I'll get to that later. That's something very non-trivial. Now, just getting to a little bit more far-out application, not a current product, let's think about telepresence. We spend our lives on Zoom these days, and so obviously it's important to think about technologies that could enhance the Zoom experience. One of them is the neural avatar, and this is from a paper that was put out by the Moscow AI Center, Viktor Lempitsky's group at Samsung Research. They got a lot of attention on Twitter last year because of this. It's a so-called deep fake, right? So from one photo, the neural net can be used to synthesize a talking head, just from one photo. From 8 photos, of course, even better. And here's the trick, not just with a real person, but with the Mona Lisa talking head. And of course, I guess our researchers couldn't resist making the Sebastian Seung talking head. And so you've heard about deepfakes. Many people are afraid of deepfakes because they could lead to bad behaviors, misleading things available on the internet. But of course, neural avatars are the good word for that, and neural avatars could be very useful for telepresence or augmented reality. And they're just a really cool application of AI. All right, so let's move on to on-device AI. As I told you before, making an AI upscaler run on a TV is a big challenge because of the limited computational resources, right? If I have a convolutional net and I want it to run on a supercomputer somewhere in the cloud, that's one thing. But if I want it to run on the limited processor of your TV, if I want it to run on your phone and not exhaust your battery immediately, or run on a robot, then we have to make a neural net that can run on device. The other bonuses of on device would be fast response time, right? No network latency. You don't have to go, the robot doesn't have to communicate with some faraway computer. It has its processing inside itself. And possibly on-device AI might be helpful for protecting consumer privacy. It's not a full solution, but leaving data on the device could be, instead of sucking it up into the cloud, could be helpful for protecting consumer privacy. So all these are bonuses of on-device AI. And you might want to dismiss on-device AI as, that's just some engineering. But in fact, I would say it's fundamental. Also, the brain. The human brain is extremely efficient in its operation. One human brain operates on 1/4 the power budget of a light bulb, a tiny amount of power. And if you compare, say, to the supercomputer that defeated Isedol in Go, many orders of magnitude difference in power consumption. And the brain has evolved to be energy efficient. That's just the pressure over the millions and billions of years of evolution that our brains have become extremely energy efficient. Not just human brains, fly brains. Imagine that a fly's brain has a lot of visual processing power and uses even less energy and takes up less space than a human brain. Now, in neural nets, efficiency means fewer connections. If you make a neural net with fewer connections, it's going to be more efficient, both in computational time, in memory consumption, and so on. And going even further, if those connections have fewer bits in them, right? You could imagine that one connection in a neural net is 16 bits, or you could imagine only one bit maybe, off or on. So the number of bits, the analog precision required to store a connection in a neural net is a big determiner of how efficient it is. And so there's a lot of interesting work going on in so-called model compression, trying to make neural nets with fewer connections and fewer bits per connection. And I'm very proud of recent work from Samsung Research, led by Dong-Soo Lee. This is one paper of theirs accepted at NeurIPS, but they also have other really fantastic papers this year on neural nets with fractional bits per connection. So really huge compression ratio, very interesting advance. And so on-device AI, if you think about it, it's a very interesting thing because on the one hand, you can imagine that AI will be inside the brains of our robots. You could also imagine that as our communication networks become more and more powerful, lower latency, higher bandwidth because of 5G and 6G innovations, you could imagine that robot would become stupider and stupider, that its intelligence would be in some faraway powerful computer. That's the idea of network intelligence, that all the intelligence will reside in the network, but not the devices. I think the reality is that there's going to be a split. Some AI will be in the robot or device, and some AI will be delivered through the network. And how that split will be made is a very interesting question for the future. So to what extent will AI be on device? Will it be running on a computer inside a robot? And to what extent will AI be delivered through the network? You could imagine that the robot itself would be dumb. It just receives its commands by communicating with some AI that's in the cloud somewhere. And that's going to become ever more possible because of 5G and 6G communication networks. The speed of communication, the bandwidth of communication between devices and centralized computers will keep on going up. So we're going to see network intelligence as well as on-device AI. And how will that split happen? It's a very interesting kind of question with a lot of implications for the future of technology. Moving on to speech and language. Speech and language are clearly important to Samsung and to many other companies that deliver computer-human interaction experiences. So here's a video from our marketing department, right? Samsung would like you to be able to talk to your smart home.
여기 이리 오세요. 잘 놀고 있어. 나 갔다 올게. 하이 빅스비. 외출 모드 실행해줘.
네, 우리 집에서 외출 모드를 시작합니다.
So you see, this is paradise. I'm living at home. I'm surrounded by Samsung devices. The home is smart. And it understands when I tell it I'm leaving, and it knows what to do, right? But that paradise will not be realized unless the home has an AI that understands our instructions. And so speech and language are very important to Samsung and to many other kinds of tech companies. And because of this, we have research in natural language understanding and speech recognition. We're very proud of this collaboration with Chris Manning's group at Stanford. Chris is going to be speaking later on in the session, but question answering is a really interesting challenge. You ask a question and the computer needs to answer you. A lot of activity on that in natural language processing, and we're participating in the Open Challenge Hotpot QA, and we're doing very well. Now, I look at all this progress in natural language processing, and I think in the end, though, we would like to have not only question answering, but we want to see multi-turn dialogue between humans and computers. You want to be able to talk with a computer in a normal way, with a conversation that goes on for a while and actually comes to the root of a problem that you're having. We have a Samsung chatbot which provides customer support, and it is able to do some interaction with the customer, but only if we constrain the domain, right? And so the challenge here is, can we build true multi-turn dialogue systems that feel natural, feel satisfying, and yet we don't have to impose all these constraints? This is the big challenge for natural language understanding. Robotics. Robotics is really, personally, a very fascinating field. Samsung actually does sell one robot, the robot vacuum cleaner. So we are already a robotics company. And we also have big plans. You can see concept robots here, which have been introduced in trade shows. For example, the Samsung Bot Chef, which is a robot that's so dexterous that it can cook for you. But in order to realize these kinds of concepts, it's clear that research is needed. Manipulation is still a very hard problem, and making something that really is commercially viable is a huge constraint on the problem of manipulation. And I'm not going to say much about that here. I just want to refer you to Dan Lee's talk. He'll talk about the problem of manipulation. And I want to pose this kind of challenge, which is inspired by the fact that there's been a lot of academic progress in research on manipulation, on grasping objects, controlling objects, and so on and so forth. And we've seen these robots on YouTube, various demos, and papers. How come we still don't see manipulating robots in real life? Why don't we have robots that wash the dishes? What is standing in the way of that? Is that just, is it that we already know the basic principles and a little bit of engineering has to be done? Or are there fundamentally new principles that need to be discovered? I think that's a very interesting topic for debate. Now, finally, health and wellness. Doesn't sound like AI. Rather, it's an area where data and devices and AI are coming together to impact human health and living in a really interesting new way. So, you've heard of smart this and smart that. You may not have heard of the smart refrigerator. Yes, Samsung has a smart refrigerator. It's called Family Hub. Of course, it has a display on the front, a touch screen. You can interact with it. It has a camera inside. So if you're at the grocery store and you want to see what's in your fridge, do I have milk? You can look inside your fridge remotely. But not only that, the AI can look inside your fridge, and it can recognize some of the food that you have inside your fridge by computer vision. And through knowledge of the food you have, it can recommend recipes to you. It can help you plan your meals. It can help you shop for more groceries that you need to cook and deliver those meals to your family. That's a food AI. And central to the food AI is a very important topic, recommender systems. And here we're benefiting from a collaboration with the Insight Center for Data Analytics, a leading academic center at UC Dublin, led by Barry Smith. And this is just showing one product of that collaboration, which is FedFast, a new twist on federated learning for recommender systems. So federated learning is interesting because it can help speed up learning, can help distribute learning, and can help ensure user privacy. So this is a very interesting area for us, and we're really excited by our collaboration with UC Dublin, which is spearheaded on our end by James Garaci. I want to mention another partnership. Samsung has partnered with Kaiser Permanente, an American health company, and this is a collaboration for cardiac rehabilitation. It's called HeartWise. And so the idea here is that we take patients who are recovering from heart problems and we give them a rehabilitation program that they can do at home through wearables and their phone. Those are taking data about them, and they can interact with their advisors remotely. And through 7 weeks, they can rehabilitate themselves. And this has a big effect on patient outcomes. Obviously, a really bad outcome is having to go back to the hospital. That's called readmission. But you can see that this program has led to a huge reduction in the hospital readmission rate. And that sounds incredible, right? Huge reduction. And my first impulse when I heard about this is to think it's about the heart. But actually, if you look closely, this is all about the head, right? If you look at the effect on these patients, normally only 50% of patients actually complete the rehab program, the typical conventional rehab program. But with this home-based virtual cardiac rehab, 90% of patients completed their rehab, all 7 weeks. And of course, that is quite likely one of the big reasons behind this much improved patient outcome. So this is showing the ability of data and devices to change people's heads, change how they behave. And so putting all this together, recommender systems, data, and devices, you can ask the question, general question, how can AI help us improve ourselves, right? Improving our health is often about changing our behavior. And maybe these technologies can actually help us in that very, very difficult task. And so I'd like to leave you with that thought, and I'd like to express my appreciation to our incredible speakers for coming out today and offering up their latest research in their lectures that we're about to see. So thank you very much for your attention. Thank you for coming. Like all of you, I'm looking forward to being educated about the latest advances in AI. Thank you very much.